Hello, this is the Verilog code of our Tetris game. Tetris is a game where different kind of geometric shape falls through a playing field. These geometric shapes are called tetriminos. Tetris have mainly 7 kind of tetriminos. This is I block, this is J block, this is L block, this is O block, this is Z block, this is T block, and this is S block. In our Tetris game, we have created two kind of blocks. This is I block and S block. At first, we have created our low frequency clock. The internal clock of the FPGA board is of very high frequency. It has a frequency of 25.175 MHz. At this frequency, the game is unplayable. So we have created our low frequency clock. This low frequency clock has a frequency of 8 Hz. So 8 terminal block will fall in 1 second. Okay. The next part of the code was 2D to 1D conversion. Through our code, we have used 2D positional data as 1D indexing because by 1D indexing, it is so much easier to implement and display using the lat matrix. Here we have used 2D positional data as 1D indexing by this segment. Here this point as 2D positional segment has x is equal to 2 and y is equal to 2. It is converted to 1D indexing by this formula I is equal to y cross w plus x, where w is the width of the matrix. So in 2D positional system, this is x is equal to 2 and y is equal to 2. In 1D positional system, this is I is equal to 10. Okay. After 2D to 1D conversion, our main game engine started. At a terminal blocks stop falling through the playing field if it encounters an already existing block or if it reaches the last row. For collision detection, we have introduced a new variable called does not fit. Here in this code segment, the collision detection was done. In this code segment, when a tetromino block finds another tetromino block in its way, the does not fit variable becomes 1 and the block stops falling. Okay. The next part was storing the row. Y flag variable was used for it. Okay. The next part was line detection. If we find an entire row of 1, then the line is cleared from the playing field and the previous line falls in this empty space. Here the line detection portion was done by it. When an entire row becomes 1, its value becomes 255 in decimal value. So when y flag j is equal to 255, the entire row is cleared from the playing field and the previous row falls in this empty space. Okay. The next part was last row detection. When a terminal block reaches last row, the does not fit variable becomes 1 and the terminal blocks stop falling through the playing field. The next part was rotation and movement of the terminal block. When the rotate button was pressed, the terminal block rotated 90-degree clockwise. Okay, the next part was movement of the block. When the left or right movement button was pressed, the block is shifted 1 unit left or right. So this was a terminal block, and all the code and its segments were discussed detailed in the report. Thank you.
This is the circuit of Tetris game using both Arduino and Proteus. In Arduino, we will do the coding part and the Proteus, and in Proteus we will do hardware simulation part. So Arduino code will be discussed shortly after the simulation. Now we will show you the different parts and parameters of Proteus circuit and how to play this game. We are using a MAX 7219 8x8 LED module. The MAX 7219 is an IC designed to control 8x8 LED matrix. The MAX 7219 input interface is a 16-bit serial input shift register. The first 8 bits define a command while the second 8 bits define the data for that command. Now let me show quickly the module in Arduino. Basically, basically we are building this with Proteus. We can find this equipment directly, but in Proteus is a little bit harder. Now we are also using an analog joystick for controlling the blocks, but there is no such library in Proteus for an analog joystick. So we build the circuits with two potentiometers and a push-pull button. Two potentiometers and a push-pull button. The first potentiometer controls x-axis movement and second potentiometer controls y-axis movement, and the push-pull button is designed for rotation of blocks. Now it's time to demonstrate the game. We mainly use two blocks, basically I and S block. It's a little bit hard in Proteus to control the blocks, but we will try our best to demonstrate the game for you. So we have to run the code in Arduino. This is Arduino code. And then we have to take the hex file from here and give input to this Arduino Mega. So the game will start shortly. So I am now turning the left and the block will go downwards. Another block we have to take it right, so it will go right now. Now I am taking it downwards. We also take it to right. Okay, so let me take it to left. Okay, it's a little bit hard to match all the rows, so we are basically giving you an example only using the vertical I blocks. So I am using here, we are giving 1 to the block input, and this will only select the vertical I block. So let me run, compile it. Okay, done compiling. Now we can run this, and only vertical I block will appear. Let me take it to the left. And take me this to right. Okay, this will go downwards, and all rows are matched, and this will disappear. Okay, we stop. Okay, and now it's time to understand the code and what we're doing in Arduino.
Hello, my name is Ataher Shams. My student ID is 1606105. I will be showing you the Arduino code that we use for the Proteus circuit. This is the flowchart we used. After setting up the setup block and declaring global variables, we will randomly pick a block. We have used two types of block here, block I and block S. We can implement more blocks if we want, but we tried to make this code simplified. After picking up the block, we will go through two types of orientation that can be either vertical or horizontal. Then we will automatically check our adjacent panels if the adjacent LEDs are on or off. According to that, we can move our we can move our block to left or right. That we will do with our move controls. That means left translate function and right translate function. At last, we will check if any of the line or if the row has all LED on. If so, we will break the line, and we will also check for columns if they are full, so that game over function can be initialized. The get over function, line break function, and set LED and get stars function are included in the LED control.h library, which we have collected from the internet. Now we will look at our main program. Here we have included LED control.h library so that we can use it in our main Arduino program. Row input and column input has been defaulted to 7 and 3 so that the blocks will always fall from 7th row and 3rd column. The X pin and Y pin are declared as such that such was in the Proteus connection. The address is 0, which we will always set to 0 because we are only using one module. The R0 is the block orientation, which can be set to 0 or 1. 0 means horizontal and 1 means vertical. There are some check variables which will check our adjacent LEDs so that we can be sure if we can move our block to right, left, or down. In the main setup function, we turn all the LED, then we set the intensity to 8 and clear all our display, all the LEDs of our display. Then we use switch to initialize the blocks. There will be two cases for the values of R0. We are assigning R0 a random value of 0 or 1. If it is 1, then we will go to the horizontal block, and if it is 0, then we will go to the vertical block. First, we take inputs through our joysticks. Then we set our columns to a fixed position here. Because we have a 8 into 8 algebra matrix, we don't want our blocks to go out of that matrix. So we set this criteria or boundaries so that our blocks always stay in the matrix. Then we check if our adjacent LED matrices are on or off using the left check 1, right check 1 functions. What I mean by left check 1, right check 1, or in future we will see check 1, check 2, check 3, check 4. I will be showing you in the diagram right now. If we see here, left check 1 is checking if the column 6 of this horizontal eye orientation block is on or off. Right check 1 is checking the right side of this eye horizontal orientation is on or off, and the check 1 to check 4 are checking if the next row, or you can say the previous row as my indices, that if they are on or off. If our left check is 1 and our right check is 0, then our block can move to right, but he can't move to left. If our left check 1 is equal to 0 and right check 1 is equal to 1, then it cannot move to right, but it can move to left. If both of them are 1, then it cannot move on to both sides, and if they are both 0, then it can move to both sides. It can move to right and it can move to left. If we see here, they are calling the functions right translate, left translate, and down translate as they are going in. So we will now check what does our right translate and left translate function does. Here we can see our right translate and left translate function. They take the column long and state as the input. The state has been set to true or false using our left check 1 and right check 1 variable. Then it will wait for our joystick input. If our state is true and the joystick is moved to right, then our columns will shift right. And if the state is true and joystick is moved to left, then our columns of the blocks will shift left. In either cases, if the states are false, moving the joystick will not change the column none of the blocks. After that, we will be dropping our block by one row in every 225 milliseconds and initialize our corresponding block function. For I block, we will be calling the I block function, and for S block, we will call the S block function. If we go to the I block function now, here, we can see it takes 4 things as its input. First of all, its address, which is set to 0, its row num, column num, and its orientation num. First of all, what we will do, if it is in the horizontal orientation, that means it will initialize case 0. First of all, we will set our previous block LED locations to false, that means to 0, and set the new LED locations to 1 or true. Then we will use check 1, check 2, check 3, check 4, left check 1, left right check 1, these variables to get the status of our adjacent LED panels. Then we will restore, we will move the values of the rows, columns, orientation, and address to the to address previous, row previous, column previous, and are not previous, and then we will break our function. And if we see for the vertical orientation, it is almost the same. Each time after successfully calling the block function, if we go to our main loop, yes, each time after successfully calling our block function, value of this R will be automatically updated. If any of the check 1 to check 4 are 1, then we will do a bottom LED check, and when the block successfully reaches the bottom, we will initialize a new block here. We will do the same thing for the next block. Each block has somewhat a different adjacent LED, so we quoted all the blocks needed to run. In this case, there are 4 types of blocks, so we are using 4 different do while loops to initialize these cases. After that, we will call on our line break and game over functions from the corresponding library ledcontrol.h. The functions were described earlier. They check if there is any row where all LED is 1, which will instigate line break function, and if all LED of a certain column is 1, then it will instigate the game over function.